Hello, I welcome you all to your own channel Learnium. Now in this video we will see the Stokes theorem. We already discussed the divergence theorem as well as the green theorems, right? Now this is the last theorem for the vector integration, that is the Stokes theorem. So Stokes theorem is nothing but it's basically the transformation between the line integral and the surface integral, right? So let S be an open surface bounded by a closed non-integral non-intersecting curve C if vector f is any differentiable vector point function, then according to the Stokes theorem, that is line integral of f dot dr is equal to surface integral of curl of f dot n ds, right, where f is nothing but the scalar vector point function and n is the unit normal vector, right? So here you have a curve, that C curve is there which is non-intersecting and S is the surface. So the Cartesian form of the Stokes theorem is what? The Cartesian form of the Stokes theorem is in this format, that let f is a vector point function whose f1i plus f2j plus f3k, and let n is the unit normal vector, n is equal to I cos alpha, j cos beta and k cos gamma. We have to find out the curl, that is del cross f, right? Del cross f, how you find, you already know right now. So that f dot dr will become like that, that is f1 dx plus f2 dy plus f3 dz, right? This is what you have a Stokes theorem, Cartesian form of a Stokes theorem. So in Cartesian in Stokes theorem, this is the transformation between line integral to the surface integral, and that expression is that line integral of f dot dr is equal to surface integral over the curl f n ds, right? So now we will see with the working example that how to verify the Stokes theorem and how we implement in our problems. Right now, here with the one problem we have taken, see that on the screen, that verify Stokes theorem for the function f is equal to x square I plus xyj integrated round the square in the plane z is equal to 0 whose sides are along the line x is equal to 0, y is equal to 0, x is equal to a and y is equal to a. So one vector point function is given whose the equation is like that, x squared I plus xyj, means it is on the xy plane, z plane is 0, right? And it is integrated on the square plane where z is 0 and x is varying from 0 to a and y is varying from 0 to a, right? So we have to verify the Stokes theorem. So for verifying the Stokes theorem, what we have to do, basically we have to find out the line integral of f dot dr and the surface integral of the curl f dot n ds. If those LHS and RHS are equal, it means that the Stokes theorem is verified. Here we go again, see. So let's begin, right? So now we can write that given and all those things as we are doing. Okay, so here is the solution, right? You can say given vector f is equal to, what is given, x squared I plus xyj, right? X squared I plus xyj, is it or not? Right. Then by a Stokes theorem, what is the Stokes theorem? Basically we will write down the expression that by, or according you can write by Stokes theorem, right? First of all, that line integral is transforming into the surface integral, which is in that mathematical expression of line integral of C f dot dr, right? F dot dr is equal to surface integral of the curl f dot n ds, is it or not? Or in another form you can write this also earlier and this one is the later on, right? So this we can write like that also, that is surface integral of, whenever you have to find that curl is nothing but the del cross f, is it right, into n ds is equal to cyclic integral over the, this is vector f, so f dot dr. All right, okay. So let's say this is the LHS and this is the RHS. For verification you have to show that LHS should be equal to RHS. So first of all I'll find out the del cross f, that is curl we have to find for vector, which function vector, for this vector, right? So let's go here, that we can write, just hold on a second. Okay, so now we can say that del cross f we are going to find. So as you know very well, so del cross f, is it, so we have to find like that, determinant of I, j and k. All right, so these are the vector. You can write like that, and like that. So here we have a dou by dou x, this is what we have a dou by dou y, and this is what we have a dou by dou z. Any problem? No. X coefficient, I coefficient, we can see from the given equation, that is, this is x square, right? And yj is the xy, and it is z plane is 0, so z is equal to 0. So simply you have to do the curl, right? How to find the curl, you know, I think that this column and this row will be hide I, this 0, its partial differentiation with respect to y of 0 is 0, and here we don't have a z, so it will be 0, right? So it means that I into 0 minus, when we take this column and this row, j we have to take, right? And we are differentiating this, means this and this one. So here again we don't have a z, and here it is 0, so it will also 0 plus k, right? So this column and this row, so you have to differentiate this x and this x square with y. So when you differentiate this x with y, you'll get the values as a y itself, right? So del cross f, basically how much we got, that, or you can say the curl of f is nothing but the vector ky, this we got, right? Now then what we have to do, that we can write LHS. We have taken as I show you that surface integral of del cross f into n ds, right? So here we can say that left hand side, which means LHS, right? So that is surface integral of del cross f into vector normal, unit normal vector n into ds. That is nothing but del cross f, just now we find that ky, right? So this is what we have, a surface integral of y, okay, into normal vector n into k into ds, okay. Now so if you see, then nk ds, right? Nk ds is nothing but the dx dy, is it? Right. So here you can write, this equation will become, that is directly I can write that surface integral of del cross f into n ds is equal to what? Is equal to y dx dy. All right. So for better understanding, here you can write, since this is vector n, vector k, dx is equal to dx into dy, right? Okay, so this you got surface integral of this one, right? Now we have to find out this values, that is y into dx dy, we have to integrate. So if you look at that, x and y is varying from 0 to a, is it or not? So therefore we can write, therefore that curl of f into n ds is equal to what? That is double integrate. Surface integral means you have to double integrate, and volume integral means that is cyclic integral, in the sense is volume, triple integrate. So 0 to a, and this is also 0 to a, and we are differentiating y into dx into dy. First we have to differentiate, integrate with respect to y. So y integration is what? Y square by 2. When we put the limit 0 to a, you'll get the a square by 2. So second time it will become, that is one integration we did, and we put the limit. After doing this, we'll got one more integration we have to do, that is 0 to a, and the equation is nothing but it is a square by 2 into dx. A square by 2 is a constant, we can take it out, and dx integration is a x. Further you have to put the limit, okay. So while you put the limit, it's become a, right? So a into a square by 2 is nothing but the a cube by 3. So it means that on simplification, this you'll get, that is what you can write, that is curl of f into n ds is equal to a cube by 3, sorry, a cube by 2. This is your LHS, this is your LHS, right? Now for a Stokes theorem, line integral should be converted into surface integral. So surface integral value you got a cube by 2, so line integral will also be a cube by 3. If it is so, it means LHS would is equal to RHS. It means that the Stokes theorem has verified. Now come to the RHS hand, that is we can say RHS, right hand side, is equal to what? That is cyclic integral of vector f into dr, right? So Cartesian form of f dr is nothing but the f1 dx plus f2 dy plus f3 dz. But for the given equation, whatever the vector point function is given, on z plane it is 0, right? So only dx and dy will come, and the x coefficient is x square and the y coefficient is xy. So this its Cartesian form of the given equation is become like that. That is cyclic integral of x square dx plus xy dy. All right, now so then we can say that is what f dr. It is that it's mentioned that integrated round the square in the plane z is equal to 0, whose sides are along the x is equal to 0, y is equal to 0, x is equal to a, and y is equal to a. It is mentioned in the question already. So here what we do, we will show one square plane, right? So here we go that further. Let's say this is your xy, right? So this is your x axis and this is the y axis. Okay, so it is the coordinate. Let's say this is 0, means O, and here the coordinate is 0 comma 0, right? So x is moving from 0 to a, right? And this we can give the name as a, right? And further the y is varying from here, the y is 0 and it is varying from 0 to a, so it is a value, and again it is parallel, that is this is for x, right? So this name is b and this is the c. So OABCO is an square, right? So here you have a, that is what x is equal to, here you have a, and here the x is equal to 0, right? And here the y is equal to 0 and here the y is equal to a. All right, so this coordinate you can say 0 0 0 comma a, and this is what you have a comma 0, all right, and 0 comma a, right? So here you have a comma a itself, right? So now we have a four reason we got means for a square how it is forming 0 to a to b to c, and c to o. So cyclic integral means you have to, whatever the integration we got f dot dr, so this is in the form of like 0 to a f dot dr plus a to b f dot dr plus b to c f dot dr plus c to o f dot dr, right? Then it cyclic will be formed, right? So now, and f dot dr is equal to this one, that is in the Cartesian form we got. So here we can write further, just a second, yeah. So now, so here you can see, all right, so here that is cyclic integral of f dot dr is equal to what? Just now as I told you that O to A vector f into dr plus a to b vector f into dr, right, plus b to c f into dr, plus final you have a co f dot dr. All right, so one by one we will find for the reason OA, AB, BC and CO, right? So now first we'll go for the, here you can write that along OA, right? So if you look at that schematic representation, how we represented the square, so this is your OA line, right? So on OA the y is equal to 0, is it or not? So as the y is equal to 0, it means that its differentiation dy will also 0. So we'll put y is equal to 0 and z is already 0 on that given plane, right? So along OA you can say, sorry, y is equal to 0, so dy is equal to 0. But on OA what is the we have to find, that is OA f dot dr is equal to what? Is equal to, I'll show you, that is f dot dr is equal to what we have written, that is x square dx plus xy dy, right? So for the along OA y is equal to 0, it means when you put y 0 this term will be 0, so we can eliminate, right? So while we eliminated, so only that, and you have to integrate from, limit is what? Limit for OA is nothing but a 0 to a, right? Limit, how you are taking the limit, it's very important that you need to take the limit for OA it is 0 and to A. All right, now so here it become like 0 to A x square dx, right? So while you integrate, it's that you can get here 0 to A, right? X square dx is equal to x square integration is x cube by 3, and when you put the limit A, it will become A cube by 3, right? So means for this you got this one, is it or not? Let's move to the next what is called, we can say along AB, right? So if you look at AB, that on AB x is become what? A, right? So along AB x is equal to A, so A is having some constant value, right? So its differentiation will be 0, that means dx is equal to 0, right? And dz is already 0, so here you have a curve what is called AB f dot dr is equal to we have a limit is what? Limit is here f dot dr for AB also limit is from 0 to A itself, right? So this is 0 to A, but in this case that x is become 0 and dx is 0, so this term will be 0, so only you have a what? That is x y into dy, but x is 0, so this is also 0 y dy you can say, right? So which is nothing but the 0 only, right? So on AB, that f dot dr AB is the 0 we got. Just hold on. So x is equal to, sorry that I'm very sorry that x is not 0, so this is what you have a y dy, so a you can get common, and this is what limit from 0 to A, y square by 2, and this will be become A cube by 2. All right. So now next is the along, there is a little bit mistake we did, along BC, right? On again BC, y is equal to A, right? So dy is equal to 0, and that what we have to find BC, is it or not? So f dot dr, see everywhere we have to put that f dot dr is equal to what? That x square dx plus xy dy, right? So x square dx is we have xy well we put that is equal to, I'll show you, limit is what from here, that is limit is A to 0. Why? That's in CB we are taking the A to 0. Why? Because you can see that's how we are moving to this side, right? So here that value is A, and here the value is 0 right now. So we have an upper limit, lower to upper is nothing but a 0, A to 0, right? So this is what you have a x square dx plus xy dy, right? So in this dy is 0, so this term will be eliminated, and only you have a limit from A to 0 x square dx. Again its differentiation integration with the dx is x cube by 3, and while you put the limit you'll get the minus A cube by 3, yes, minus A cube by 3, right? So ABC we got. Final last, that is for cyclic, that we can say along CO, right? So again on CO we have a x is 0, right? X is equal to 0, so its dx is obviously it is 0, right? So while we put that is CO vector f dot dr is equal to this limit is what? Limit is again A to 0 itself, and this is x square dx plus xy dy, is it or not? So x is 0, this is 0, here also x is there, so that x is 0, so this integration will be 0. Now we have to find out the cyclic integral of f dot dr, that is nothing but the OA plus AB plus BC plus CO. So now you can write that is cyclic integral of vector f dot dr is equal to what? That is AB f dot it's not AB, it is OA first, f dot dr plus AB vector f dot dr plus this is BC f dot dr plus this is CO f dot dr, right? So all the values you calculated, just put this these values. So OA we got A cube by 3, all right, and AB we got a cube by 2, all right, and BC we got minus a cube by 3, okay, plus CO we got 0. So a cube by 3 plus a cube minus a cube will get cancelled. So what is remaining you have, that is a cube by 2, right, which is nothing but the cyclic integral of, you can say, f dot dr. This is the RHS, right? And now it's the time to compare this, that you find that LHS is equal to RHS. Why? Because del cross f dot nds you already calculated, that is a cube by 2, right? So here you can write hence the Stokes theorem verified, right? So this is how we can solve the problem which is related to the Stokes theorem. These are all the vector integration theorems are completed. Please do like, subscribe our channel. Thank you.